Basically, an infinite geometric series is where the ratio is a proper fraction in between -1 and 1. And you have something like, it's called infinite because let's say we take 1, and let's say my common ratio is 1/2. So if the common ratio is 1/2, we're going to write let's go ahead and just write as a sequence, sort of. What's 1/2 of 1 is 1/2. What's 1/2 of 1/2? 1/4. 1/8. I'm just taking the ratio. 1/16. 1/32. 1/64. And so forth. 1/128. Dot, dot, dot. It's infinite because this will never stop. So the key to infinite geometric series is that it's a proper fraction, and if it is an infinite geometric series, it will never stop. But we can find the sum because it's going to get closer and closer to 0, so we can find the sum. And it's a very simple formula. It's S equals A, and I'm saying A is the first term. So if I just write A, we know that that is the first term. So I don't have to keep writing it. And then it's going to be 1 minus R. And that's your sum. Okay, so let's do some problems. We're going to find the sum, if it exists, of infinite geometric series. So they give you the first term is -7. Again, I'm not writing the 1. If I just let A equal ace of 1, then that's the first term. And R is 5/8. So the sum is just going to be A over 1 minus R, which is -7 over 1 minus 5/8, which basically is -7 over this. I can change this to 8 over 8, which is 3/8, which is -56. This is 7 over 3, and you can just leave it like that, or you can write that as -18 2/3. Okay, so let's find the sum where the first term is 4 and R is 1/2. So the formula is going to be 4 over 1 minus 1/2, which basically is 4 over 1/2, which equals 8. Okay, and let's do one where they just give you a list. So they give you a list of some numbers. 2/3. That would be your first term. Not 2/3. Let's make it 2/9. Plus 5 over 27. Plus 25 over 162. So I know my first term. And to find my common ratio, I take this term divided by the previous term, which is really times 9 over 2, which gives me 9 goes into that 3 times. So my common ratio is 5 over 6. So I'm going to write my summation formula as 2 over 9, which is my first term, over 1 minus 5/6, which is 6/6 minus 5/6, which gives me 2 over 9 minus 1 over 6. And of course, you all get to use the calculator, and that's going to equal 4/3 or 1 1/3. Okay, let's do this one. We have 1/10 plus 1 over 20 plus 1 over 40 plus dot, dot, dot. All right, we get to find the sum. To find the ratio, that's 1/10 over 1 over 20, which is the same as 1/10 times 20 over 1, which would mean basically what we're doing is we're multiplying by 1/2. I don't know why I'm coming up with something weird here. So dividing oh, I know why, because I did it wrong. So basically, don't do what I just did. You take the current term, divide it by the previous term. So that's 1/20 over 1/10, which is going to give you 1/2. And basically, you don't even have to do that. You can see we're multiplying by 1/2 here, right? So my sum is just going to be my first term over 1 minus 1/2, which is 1/10 over 1/2, which equals 1/5. Okay, let's do another one. We have 6 minus 12 plus 24 minus 48 plus dot, dot, dot. The common ratio equals -2. Since -2 is not in between -1 and 1, the sum does not exist. So you're going to put does not exist. The common ratio has to be in between -1 and 1. In this case, it wasn't, so it doesn't exist. All right. And another one, we have some basic. So this is basically really easy. We're going to have, we need to find the first 4 terms when we have the sum is -16 and r is 1/4. So when you have something like that, you don't know what a is, or the first term. So we're going to just use the formula. -16 equals a over 1, which is 4 over 4, minus 1/4. That gives us a over 3/4 equals -16. When you cross multiply, you're going to get a equals -12. Now, when you do that, all you have to do from there is they want the first 4 terms, comma, comma. So they want a sub 1, a sub 2, a sub 3, and a sub 4. So we have -12, and basically we're just multiplying by 1/4. So we get -3, -3/4, -3 over 16. Okay? Let me try to do another one. Let's try the first 3 terms. So the sum is 64, and r is -3/4. So we're looking for a again, the first term, over 4/4 minus a -3/4, which gives us a over 7/4 equals 64. You cross multiply and you get a equals 1/12, and we want the first 3 terms. And the first term is 1/12, and then you're just multiplying by -3/4. You're going to get -84 and then 63. Okay, and basically we're supposed to be adding these because it's a series. And you just do it like that. And that's all for this. We'll do more book work on this later.